Lesson 8.2, volume of cones. Our objective for the day is to be able to find the volume of cones. We do have one vocabulary word in this lesson, which happens to be cone, as you can see on this page. A cone is going to be a three-dimensional figure with one circular base connected by a curved surface to a single vertex. So basically what that means is, in comparison to a cylinder, a cone is going to come to one point. All right, in this visual you can see here the point is up here. Sometimes your cones can be turned around. For instance, if you think about an ice cream cone, the tip of an ice cream cone would be at the bottom. But again, you still have your circular base here. Okay, we're still going to have a height. You can still see your radius here, and then it comes to the single vertex at the top. So that's the cone, and again, we're going to be focusing on finding the volume of it. So the volume of a cone, as we look at our figure, or our formulas, excuse me, we have two formulas we can look at. The first one is V equals 1/3 capital BH, or we can think V equals 1/3 pi times radius squared times height. If we go back and think about what we learned in lesson 8.1 when we were finding volume of cylinders, we will recognize that we were looking at V equals BH or V equals pi times radius squared times height. So basically we're thinking the same thing, except for when we're finding the volume of a cone, we're thinking in terms of 1/3 of that. All right, a cone is only going to be 1/3 of what that cylinder was. So the only thing that is going to be changing is the fact that we're still going to be taking our area of a cylinder, but we're taking it times a third. Just a friendly reminder that remember the capital B stands for the base area. Again, you have an area of a circular area, circular bottom, so the area of a circle is pi times radius squared. As we take a look at example 1 here, they're asking us to find the volume of the cone rounded to the nearest tenth. So just looking at it, I can see that my radius down here is 3 inches. I can see that my height is going to be 6 inches. So I should be thinking the base of this is a circle, so I'm thinking pi. All right, they're not asking us to use 3.14, so we're going to type in our pi key. The radius is 3, and then our height is 6. And again, we're thinking times 1/3. So on your calculator, you can use your ABC key. Just go ahead and type 1 ABC 3, and then times pi times 3 squared times 6. And hopefully when you type that in your calculator, you're going to get your volume to be approximately 56.5 cubic inches rounded to the nearest tenth. Again, they're using the approximation symbol here because they're rounding to that. If I was writing this in another way, I could put 56.5 and I could have inches and then raised to the third power. If you would take a minute right now and go ahead and pause your video and try A and B. When we take a look at A and B, okay, A is giving us a cone that has a radius of 2 feet and a height of 7 feet. So again, I should be thinking V is going to equal 1/3 times pi times my radius, which is 2, and I need to square that, times 7. So I would recommend, again, practicing writing your formulas out on these when you are doing these, just to get in the habit of them and remembering what they are. Utilizing the numbers they have given you, hopefully you came up with 29 3/10 cubic feet. As we take a look at letter B, this one's turned to the side, so we got to think about what they're giving us. Again, we're thinking V equals 1/3 times pi. In this case, they're giving you the diameter, so you're going to notice here they go from this point to this point, which happens to be the diameter, which is 12. So hopefully we didn't get stuck on that. Remember, we're talking about the radius. So the radius is half of the diameter, so I'm using the number 12. I'm going to square it, and then I'm going to times it by 26. So our answer for got it problem B should be 3,920.7 cubic millimeters. Looking at example 2, a cone-shaped paper cup is filled with water. The height of the cup is 10 centimeters and the diameter is 8 centimeters. What is the volume of the paper cup? Round to the nearest tenth. Again, we're using our volume formula for a cone. V equals 1/3 times pi times radius squared times height. So I'm thinking V equals 1/3 times pi. They are telling me that the diameter is 8, but I need the radius, so we're going to use 4. Remember, 4 is half of 8, so I'm going to use 4, and I'm going to square it, times it by the height, which is 10. So when we plug this into our calculators, we should get about 167 6/10. Unit is being measured in centimeters, so it will be cubic centimeters. Looking at the top of the next page, they have given us Got It Problem C. So as we take a look at Got It Problem C on the top, we can see here they're giving us a word problem. April is filling 6 identical cones for her piñata. Each cone has a radius of 1.5 inches and a height of 9 inches. What is the total volume of the cones? Now I caution you on this one because if you remember, okay, there are 6 of them. So you have to be very, very, very careful of how many there are. They're not asking you for one of them, they're asking you for 6 of them. So go ahead and pause your video right now and try figuring out what your volume of your 6 identical cones for your piñata is going to be, rounded to the nearest tenth. After you have done your math, you're thinking V equals 1/3 times pi times radius squared times height. So we're thinking V equals 1/3 times pi times radius, which is 1.5 squared, times height of 9. And then when we get our answer, we need to take that times 6. So our answer, rounded to the nearest tenth of the volume of the 6 identical cones, should be about 127.2 cubic inches. Last but not least, looking here, they're also talking or introducing volume of composite solids. We had talked a little bit about this in lesson 8.1. So what they are going to be doing is putting together at least 2 solids for you. In this example, they're giving you a cylinder and a cone, so it takes us back to the previous lesson where we worked with cylinders, and they are asking us to find the volume. So what you need to do is you need to think of these as 2 separate pieces. Number 1, finding the volume of the cylinder. Again, volume formula for a cylinder is pi times radius squared times height. Looking at your measurements that they are giving you, they're telling us that it's 8 across, which is your diameter. So again, we have to think in terms of a radius. Radius is going to be 4. So pi times radius squared times the actual height of just the cylinder is 4. So they found the volume of the cylinder. Then we need to find the volume of the cone at the bottom. So we should be thinking formula for the volume of a cone, 1/3 times pi times radius squared times height. So again, using the information that they have given us, we're thinking 1/3 times pi. Again, we can use this top number up here of 8 feet, thinking that that's what it would be down here as well. This is the diameter, so we're thinking half of that. So 4 squared times the actual height of your cone is 5 in this case. Once you have the volume of your cone, then you can go ahead and add those 2 together and then get your answer. Got It Problem D is an example similar to the one that we just did in exercise 3 or example 3. So take a minute right now and look at that composite solid. In this case, you have 2 cones. Pause your video, go ahead and work on it, and then see if you come up with the correct answer. As you can see off on the right-hand side, okay, they have come up with 697.4 cubic inches when we are looking at the volume of that composite solid, or the volume of those 2 cones that are put together. Again, you can go ahead and utilize the guided practice, the independent practice, or the extra practice problems that would be in your ebook or in your actual book. Another practice problem that you could work on could be your Common Core review, which is on page 604 in your book, which goes back to finding the volume and reviewing that if you choose. I did also attach practice problems with answers on the 3rd slide of this PowerPoint.